Hello, I'm Tim Burcham, Director of the Northeast Rice Research and Extension Center, or the NERREC as we refer to it here. Today I'm joined by Arlene Adviente-Borbe with the USDA ARS unit. That's the Delta Water Management Research Unit. Arlene, welcome.
Thank you, Dr. Burcham, and hello everyone. My name is Arlene Adviente-Borbe, and I am a research agronomist for the Delta Water Management Research Unit here in Northeast Arkansas. Today we are in the NERREC farm, and you are looking at our field trial on greenhouse gas emissions and grain yield response on furrow rice irrigation. We are working on different rice varieties and their responses under flooded and non-flooded irrigation systems.
So Arlene, I know out here we have some different hybrid varieties as well as a pure line variety, and also row rice as well as mirror irrigation types. Can you just share briefly about those types of irrigations and what methodologies and why we're looking at those management practices?
Sure. In this research field, we are studying two different flooding systems for rice. One is MIRI, which is a continuously flooded system, which everybody are familiar with. And we are also having another non-flooded practice, and which is the row rice or intermittent irrigation, or they also call it aerobic and anaerobic rice cultivation. We are testing these two non and flooded rice systems to understand the response of different rice varieties in terms of yield and greenhouse gas emissions. And at the same time, we also would like to know the potential of rice varieties to mitigate greenhouse gas emissions under flooded and non-flooded conditions.
Great. Well, Arlene, as I've come down and we've been going through the growing season, I noticed a lot of different individuals here. So you have a large group, and this type of research requires a great team. Can you talk to us about the team that you put together for this particular research project?
Yeah, we have quite an army of people, researchers who have expertise in different fields. We have a postdoc research fellow from the University of Arkansas in Fayetteville, Dr. Sanja Karki, and she is an expert in nitrous oxide emissions and greenhouse gas emission calculations. She basically manages our greenhouse gas measurements in this field. We also have a 30-year rice agronomist from the International Rice Research Institute, and his name is Wency Larazo, and he is responsible in the phenomics, staging of the rice crop, as well as measuring yield components and grain yields in this field. The third one in our team is Dylan Tillery. Dylan is a researcher, graduated from Arkansas State University, and who would like to be an expert also in rice research and other crops. The fourth one is a federal employee, Benjamin Levenbach. He is a physical science technician who just came on board, and he is responsible in the measurements of grain yield as well as greenhouse gas emissions with Dr. Karki. And last but not the least is Andre Monsalud. Andre is our student. He's an undergrad student from the Arkansas State University as well, and majoring in biological sciences. He would like to gain more experiences in experiment environment, as well as dealing with sensitive instrumentations as well as measurements of rice and cotton here in Northeast Arkansas.
Great. You've got a wonderful team, Arlene, and they've been very thorough in their work out here and very consistent, so we really appreciate that. Arlene, can you provide us some background information on the research that you and your team are implementing here at the NERREC this year? So kind of the big picture, a wide scope of what we're doing, what you guys are doing here, and the relevance of that information for our rice growers.
Sure. It has been reported, and it's been known from many scientists, that global warming potential is very high in rice among other cereal crops. Why? Because of the methane emissions coming from flooded rice. And also nitrous oxide, another greenhouse gas, is high in rice paddies or rice cultivation because of the drain period at the end of the season. Now together, when you add these two greenhouse gases, it entails higher global warming potential. We also found out in our previous studies that rice varieties, specifically hybrid rice, have the potential to reduce methane emissions. And with the combination of non-flooded system and a potentially lower emitter of methane, we could come up in a very effective conservation management that would reduce greenhouse gas emission and at the same time sustain the yield. In this field, our focus is mainly looking at management systems that would give the rice farmers their advantage of having higher or sustaining the high yield of their field and at the same time lowering the potential to emit higher greenhouse gas emissions, just like methane and nitrous oxide.
Okay. Well, with regard to your research focus there, who are some of the major collaborators that are working with you on this particular research project?
So in addition to the USDA ARS, we are also working or collaborating with many institutions. One, we collaborated with RiceTech Incorporated. We are looking at some of their hybrid varieties to test whether there is a negative response in terms of greenhouse gas emissions and at the same time having their yield sustained under flooded and non-flooded conditions. We also have the University of Arkansas, the Division of Agriculture with you, Dr. Burcham, because we would like to have support in terms of the managing of this field and at the same time helping us to measure grain yields with your equipment and also the expertise coming from your group.
Great, thank you. Well, in order to achieve those goals, what type of measurements are involved in this experiment? I know I see your crew down here, and it's very technological, and you've got a lot of instrumentation here to do these greenhouse gas emission measurements. Can you talk to our audience a little bit about the types of measurements that you have going on here?
Yes, we have quite a number of measurement protocols and instrumentations in this field because there are many metrics that we are measuring in order to achieve our objectives. One is we are implementing flux chamber technique, and this is a well-known and conventional way of measuring greenhouse gas fluxes from the field. Together with a gas chromatograph instrument, we were able to measure those three greenhouse gases: methane, nitrous oxide, and CO2. We also measure water because we compare two different flooding systems. One is MIRI, or continuously flooded, and the other one is row rice, which is a combination of AWD and MIRI. And with these measurements, we have flow meters. We also have water depth. We have soil moisture content because it tells us when to reflood during the reproductive stage. We also measure soil temperature. We also measure a different response in terms of fertilizer, like phenologies. WNC is doing a lot of phenological measurements of this rice in terms of their response to different nitrogen application, and this nitrogen application, we relate that to the losses of nitrogen in the field through nitrous oxide emission. We also we will also calculate water use efficiency because we can able to measure the amount of water added to this field. So there's quite a lot of parameters we're measuring in this field. It's not only gas measurements, but the entire suite of metrics that would help us understand the benefits of having a row rice versus MIRI and using hybrid varieties and non-traditional system approach in rice cropping.
Great. Well, I know that we're glad to have you here on the NERREC farm here. What were some of the reasons that you guys wanted to set the research up here? I know you have research activities in different parts of the Delta. When we talk about the Delta Water Management Research Unit, your team has responsibilities for really the whole Arkansas Delta. What was some of the factors that led you to establish this research work here at the NERREC farm site?
Honestly, Dr. Burcham, we are very lucky to have you in this region because the Delta Water Management Research Unit does not have a lab. We do not have our own field research. So having this NERREC field farms in the Poinsett County will help us have much more measurements in terms of the field trials we are doing because of the location. It's close by. It's 20 minutes away from our lab in ABI. And also, whenever we would like to do some kind of intensive measurements, we are stone throw away from our lab and we can do it anytime. You know, gas emission measurements, it's not only one time per week, but it is intensive measurements. So if we have a far away field like an hour drive, it would be impossible for us to do intensive management. And also the reason why we would like our field trials here is because of the expertise you could bring to our team. We do not have a field agronomist, a regular agronomist who would tend the land, and Greg Simpsons and you, Dr. Burcham, have been very helpful and very supportive in dealing with growing of rice, specifically managing the rice, particularly in this type of study, because our study is a little bit controlled one because we would like to capture all those responses during the growing season, and this station is perfect to do our work here.
Well, thank you, Arlene. And you know, this of course is the first year that the farm has been back in production, and of course we've battled some issues here. This particular field is a slope of 0.3. Some of the other fields are much steeper at a 0.1 grade. It is also next to the Langue River here also, so we've got a little bit of transitional soil types that we deal with here, from a Tichenor to the Henry silt loams that are predominant here. But what a great location to do this type of research. You're in the Poinsett County, of course, which is the largest rice producing county in the state of Arkansas, and probably the largest rice producing acreage-wise county in the United States of America. And so it's a great opportunity for your team to be doing research that is in this high production area. And also, we're west of the ridge here as well, and so we're in an area where we have declining groundwater. And so just like we have a reservoir here to do our irrigation methodologies here, it's a great place for us to look at water saving methodologies going forward for our farmers in Arkansas, rice farmers. That's
true, Dr. Burcham. I forgot to mention that the other main reason why we would like our field here is because this is the place which is perfect for our field experiments, because we are also looking at water use efficiency. Yes. And Poinsett County is the perfect place to do research so that it would be doable if other rice farmers would, you know, adopt this type of practices in their own field. So we are basically in a reality of doing our measurements in Arkansas instead of a specific research station. Again, thank you, Arlene, and thanks to your team of researchers. We look forward to working with you in the future. It's a pleasure, Dr. Burcham. Thank you.